All right, 8.5 notes. We're going to do the double angle formulas today. We're going to use the unit circle to find exact measures of double angles. So here are my double angle formulas. This is the double angle for sine. Notice you're doubling, multiplying by 2 to the angle. It gives you 2 sine of the angle, cosine of the angle. This is the tangent one. Cosine has 3 of them, but I always use the top one for simplicity. So yeah. Here we go. Number 1, it says if sine theta equals 5 over 13 and sine of theta is in quadrant 2, find the exact value of each of the following. So we're going to need to draw a picture. I have a T. I'm going to draw a triangle in quadrant 2. So remember this is quadrant 1, 2, 3, 4. So draw a triangle in quadrant 2. This is going to be our theta here. And we know sine is so, O over H. So the opposite of that angle is 5. The hypotenuse is 13. We have to do the Pythagorean theorem to find this missing leg. So if you recall, Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. So that'll give us x squared plus 5 squared equals 13 squared. The square of 5 is 25, and the square root of 13 is 169. Subtract the 25 over, I'm going to get 144. Then you square both sides, you're going to get 12. But because this is going left, it's going to be negative 12, right? All right. So we're going to now plug in some formulas. So you can actually just get points for plugging it in. So this is saying to find the sine of 2 theta. So I'm going to replace the little alpha here and change it to the Greek letter theta. All I'm going to do is write down the formula. So you have 2 sine theta cosine theta, just writing that formula down below the problem. Now we're going to start substituting the ratios for sine theta and cosine theta. But I have to drop the 2 down. For sine of theta, sine is so, O over H, so that's 5 over 13. And notice they gave us that ratio, so it should be the same. Our cosine ratio is cut, A over H, so that should be a negative 12 over 13. So you have to multiply these 3 numbers together. If you want to think of this as 2 over 1, so I'm multiplying 2 times 5, which is 10, times negative 12, which is negative 120, over 1 times 13, which is 169. All right, let's go on to B. This is the double angle for cosine. I told you I always use the first one, and we're replacing the alpha with the Greek letter theta. So it's cosine squared theta minus sine squared theta. So our cosine ratio, we said, was negative 12 over 13. I am going to square that number. Minus, I'm going to square the sine ratio, which is 5 over 13. So you're going to shower the power. You're doing PEMDAS, you always square first. So squaring negative 12, that's going to become a positive 144 over 169. Minus 5 squared is 25 over 13 squared, which is 169. And how nice, we have a common denominator, so I can just subtract the tops. I get 144 over 25. That's going to give you 119 over 169. Last one is to do the tangent one. So the tangent formula is down here. You're doing 2 tangent theta over 1 minus tangent squared theta. So the tangent ratio is TOA, O over A. So that's 5 over negative 12. You can also write it as negative 5 over 12. It's the same thing. So this is 2 times negative 5 over 12. Notice I moved the negative to the top. It's the same thing. And then 1 minus that negative 5 over 12 squared. So this is kind of scary looking. This would give you negative 10 over 12 divided by 1 minus 25 over 144. This is going to become a hot mess really, really quick. So this is when we would go to Desmos. Okay, so I'm typing this into my Desmos calculator. So we have a fraction. So I'm going to go ahead and hit the divide symbol. So I have a fraction in here. So I'm going to do 2 parentheses, and then I have another fraction. And then it's going to be negative 5 over 12. In my denominator, I'm going to have 1 minus parentheses. We have a fraction of negative 5 over 12. But these parentheses are going to be squared, like so. So I'm getting this, but I want to see it as a fraction. So I'm going to click the Convert to Fraction button, and I'm getting negative 120 over 119. All right, so we can say it's negative 120 over 119. There is kind of a trick to this as well. If you think about this being the sine and cosine and tangent ratio of the same angle, sine is so O over H. So notice my hypotenuse is 169. So is this over here, right? Cosine is ca A over H. So my adjacent is 119. And then notice tangent is O over A. Well, from the sine ratio, I know my opposite is negative 120, and my adjacent is 119. So it should match. There is a way to double check just in case you have trouble typing that into a calculator. All right, number 2, same thing. We're drawing a picture. We have cosine theta is negative 4 over 5, and it's in quadrant 3 this time. So let's draw a triangle in quadrant 3. My angle theta is by the origin. Cosine is ca A over H, so adjacent is negative 4. The hypotenuse is 5. What is this missing leg? Okay, doing the Pythagorean theorem, you should be getting that the missing leg is 3, but it's going down, so it's negative 3. So we're doing the double sine formula. So that's 2 sine of theta cosine theta. Just write the formula out. And then we substitute. It's 2 times, we have sine ratio. Sine is so O over H, so that's negative 3 over 5. Your cosine ratio is ca A over H, so that's negative 4 over 5. Notice they gave us that one. What do you get when you multiply that? Okay, a negative times a negative is positive. So 2 times 3 times 4, that should give you 24 over 1 times 5 times 5, which is 25. All right, doing part B, you have the double angle for cosine. So that's cosine squared theta minus sine squared theta, just writing the formula down. The cosine ratio was negative 4 over 5, and that's being squared. The sine ratio was negative 3 over 5, and that's being squared. Shower the power, you get a positive 16 over 25 minus a positive 9 over 25. And then you just subtract 16 minus 9 is 7 over our common denominator, 25. So notice I can use my little trick where this is O over H, and this is A over H, and I know tangent is O over A. So I already know it's going to be 24 over 7, but I'm going to show all of this work. So my tangent formula is 2 tangent theta over 1 minus tangent squared theta. My tangent ratio is TOA, O over A. So it's negative 3 over negative 4. A negative divided by a negative is going to become positive. So this is 2 over times 3 over 4. And then 1 minus 3 over 4 squared. Typing that into your calculator, you will get 24 over 7, so it does check. I'm going to be looking for all of this work. All right, number 3, we're now going backwards. They're giving us the right side of the equation. We're going to go to the left side. So notice this has the word tangent in it, so we're going to use our tangent formula. So on the left side, we have tangent of 2 times whatever the angle is, which is 15. And then 2 times 15 is 30. So now I have to draw a picture of an angle at 30 degrees. Opposite is 1, adjacent is root 3, hypotenuse is 2. What is the tangent ratio at 30 degrees? Well, tangent is TOA, O over A, so you should get 1 over root 3, which rationalizes to root 3 over 3. All right, B, you have cosine squared minus sine squared. Notice that's the double formula for cosine. So on the left side, it's going to be written as cosine of 2 times 105. 2 times 105 is 210. So drawing a picture, you've got 90, 180. Going a little bit past 180 by 30 degrees. It's 30 degrees more than 180. Opposite the 30 is 1, adjacent's root 3, hypotenuse is 2, left is negative, down is negative. What is the cosine ratio? All right, cosine is cut, a over h, so it's negative root 3 over 2. All right, for this one, it's 2 sine cosine. That pattern is this one, 2 sine cosine. So we're doing the double angle formula for sine. So it's the sine of 2 times pi over 8. Well, 2 goes into 8 4 times, so it's actually the sine of pi over 4. So that's less than half a pi, so it's in quadrant 1, where this is pi over 4. The legs are equal, 1, and the hypotenuse is the square root of 2. What is the sine ratio? All right, so sine is so, O over h, you get 1 over root 2, and then you rationalize and get root 2 over 2. All right, for D, again, you have 2 sine cosine. That's the double angle formula for sine. So we're going to do sine of 2 times 5 pi over 6. 2 goes into 6 3 times. So you're left with sine of 5 pi over 3, which is a mixed number. 3 goes into 5 once with 2 left over. So it's 1 2/3 pi. So when I graph this, I go half a pi, 1 pi, 1.5 pi, 2 pi. Notice that's more than 1.5 but less than 2 pi, so it's over here. The denominator is 3, so this is pi over 3. That's equivalent to 60 degrees, so opposite the 60 is root 3, adjacent's 1, hypotenuse is 2, right is positive, down is negative. So what is the sine ratio over here? All right, you should be getting negative root 3 over 2. All right, so we get the pleasure of verifying with these problems now. So if you notice, we have sine of 2x. That means I'm doubling the angle of x. So this whole part that's in front of the parentheses here is going to get replaced with the double angle formula for sine. So we're definitely going to be simplifying the left side. And then the double angle, I'm going to replace the alpha with the letter x. So this sine 2x is going to become 2 sine x cosine x. I'm just plugging that formula in for this part here. Then if you recall, the tangent of x can be rewritten as the sine of x over the cosine of x, plus cotangent x is cosine x over sine x. I'm going to prove that all of this equals 2. So from here, you can distribute. So if I multiply this to the first fraction, I'm going to get 2. Sine times sine would be sine squared cosine x on the top, all over cosine x. Plus, if you distribute this one to the second one, I'm going to get 2 sine of x, and then I have cosine times cosine, which is cosine squared x, all over 1 times the sine of x, which is just the sine of x. That's distributing to both fractions. Hey, look, the cosines cancel, the sines cancel. So I'm now left with 2 sine squared x plus 2 cosine squared x. Hey, look, both terms have a 2, so I can factor a 2 out of both values. Think of it as a hockey stick. So if I factor out a 2 from both terms, I'm going to get a sine squared x plus a cosine squared x. And hopefully you remember this is a Pythagorean identity. Sine squared x plus cosine squared x is equal to 1. So that whole parentheses becomes 1. And then 2 times 1 is 2. And now you've proven the right side.